I'm Nick Schiffer and I own NS Builders. I get to work with a team of wildly talented craftsmen building and renovating some of the coolest homes in Boston.
Pre-con meeting for Weston Master Suite reno. We're making all the interior doors for this. A little bit different for us. We don't usually make the interior doors, so just kind of want to run through that process. Very important that they're super flat and that they're oversized, so it's going to make it a little bit trickier. This is why we can't just order them. And they're extra thick. They're going to be 2.5 finished with a 1/4 inch mirror on them, so the door itself needs to be 2 1/4. Our thoughts on construction: we're going to use an aluminum honeycomb interior. It's 1 inch thick. We're going to take LVL studs for the frame around the interior of the door, and we're going to skin it with MDF on either side. Some of them will have an oak veneer, some of them are paint grade. But we just got the honeycomb delivery. You want to go open that up? Take a look. So these are the honeycomb panels that we're using for the interiors of our doors. They're made from aluminum, and under these solid sheets is a honeycomb pattern grid that will add extra rigidity to our door. We're going to cut these panels using the track saw and a special aluminum cutting blade.
When we first sold this job, one of the first questions this client asked, and I thought it was going to be a contract question or who was going to be on site or how we were going to, format this job, was about the flatness of these closet doors. And he went into digging into what hinges we were going to use and all of these really micro details early on in the process. So I knew how important that this part of the project was going to be. Really, it has to translate into our execution.
So we started by milling down the LVL studs. We were a bit worried that removing some of the material and resins was going to compromise the integrity of the engineered lumber. This didn't seem to be the case, so we were confident in moving forward. Once we calculated our door sizes, we cut the aluminum and the LVLs to our proper width, leaving a little bit extra on either side to take off and squaring up the doors and just general trimming. Once we peel off the protective film on these aluminum panels, we're going to give them a quick scuff as per the manufacturer's recommendation so that our 2-part epoxy adheres better.
So one of the tools that is really important in this process is the vacuum bag, something we invested in just over a year ago. And what that's doing is allowing us to bring multiple materials with multiple layers of epoxy and forming them into one whole, which will become our door.
So at this point, we've leveled off our vacuum table. It's very important to make sure that it is completely level going across both ways. We don't want any twisting. Those twists and warps could telegraph into our final product, which we obviously don't want. Now that we have our platen on here, our bag set up, we've hooked up our airline through our table, our bag, and into our platen. So you see all these curves in the top of our platen? These would actually pull all of the air throughout the bag back into the vacuum pump. We use a piece of 1/4 inch melamine and drop it on the top of our bag to protect it from any glue or adhesives that might spill out onto the platen. We like to break all the edges and round over the corners so that there's no sharp edges that might puncture the vacuum bag. We'll also do this to the pieces that get put on the top that come in contact with the vacuum bag. We don't want any dust in our bag as it can cause imperfections in the veneer as well as damage to the vacuum itself. Once over at our vacuum bag, we laid out all the panels and prepped for our 2-part epoxy. All right, I'll mix up the epoxy. Blow off the other two 12-inch doors, 17-inch doors, the aluminum and the MDF, get the studs ready, and then break one of the top edges on the MDF so we can use that as our top sheet. So we tack all of our pieces in place so that during the compression of the vacuum, pieces don't shift on us. Typically we try not to have fasteners in the face of our pieces, but in this case we did go through the face because one side of each of these doors is going to get a mirror, so it'll cover any holes that we do put in the panel. So you can see here we did get a little bit of the epoxy squeeze out. It's a good sign. It's telling us that our pieces are nice and tight. Another thing we like to do is mark the time that this went into the bag so that we know when it's safe to come out. This here needs about 10 to 15 hours with this particular epoxy. So we'll leave it in the bag for the rest of the day and check on it later tonight. Once the doors come out of the bag, we'll trim one edge, where Zach will then go ahead and mortise in for an additional oak blocking.
We laid out here where we're gonna mortise for our little solid wood pieces for the backer for our hardware. First, I start by drilling out these holes with a spade bit. I'll go all the way up. That will make it a lot easier for the mortiser to route out all this material. Saves the blade and saves the tool. This is the mortiser right here. It's a porta-cable lock mortise. Typically it's used for door hardware, locks, stuff like that, but we're using it over here to take these oak pieces that we milled up. This will slide in. So we're getting ready to epoxy our oak pieces that we milled into our little mortise that we made here. This will be solid backing for our hardware. We don't want to go into MDF with screws. We don't want to go into the engineered studs with screws. So we'll pre-drill into this oak block that we milled up. And that'll be nice and solid backing for our hardware. That one should be good. So this is a two-part epoxy we're using. You just want to lather it up. We'll just make sure we get it on both inside the mortise and on the oak to get a nice tight seal. Once these dry, we will clean up our edges.
These closets are going to be used all the time. Pulling them, opening them, closing them. If they loosen up, if that screws in, the MDF material, that can ultimately strip over time, and then it's just a pain in the butt to fill and fix. And this, solid blocking will give us the opportunity to make that connection really strong.
The 12 doors that are going to receive mirrors will be painted. So in those cases, we opted for a solid maple edge banding. We'll start by edging the top and bottom.
We do the top and bottom first so that you can't see any end grain once all the edging is assembled. Now that we've got our top and bottom solid edging on our closet doors and we've got our final widths, we're going to cut them to size. Get our long side edging glued up. We're edging these doors so that they get a nice clean finish across all of the layers after they're painted.
Once our edge banding is dry, we'll trim the excess with a router. The next step in our door making process is to route in for the hinges. When it came to selecting a hinge for these doors, we made two mock-ups. We experimented with them both here in the shop and brought them to the client so they could try them out too, and it was a unanimous decision to go with the Fritz-Jurgens. Not only did the Fritz-Jurgen hinges offer us some adjustability, they were also a much smoother operation. When moving the door, they even stayed in place where you let them go. Unlike the other hinges that would move when you let them go, even though they were perfectly plumb.
Well, this hinge has a weird little detail on the bottom, so we're gonna drill this part out first, and then go back and route the plate into place. Looks like a pretty good fit. We're gonna move on to the next jig. Because the hardware on these is gonna be centered on the doors, I can take this jig and use it for both sides. So if I needed to hinge that side, I could hinge that side and it's gonna land in the same place. 3/4 inch radius corners, so we're gonna use a 3/4 inch top roller bearing bit. So that's our bottom pivot hinge. We're not gonna screw it in anything, this is just for fitment. And we'll go ahead and do the top one. So the first jig was set up to do just the plate. This next jig is gonna go a little bit deeper and make sure that this has all the clearance it needs. We're gonna pre-drill again because that's a lot of material to take off, especially with the bits that we're using. It doesn't need to be pretty, it's all gonna be cleaned up with the router. So from here on out, we're not gonna be using any more jigs. We're gonna use the mortise we just made with our last jig as a jig to go deeper into our opening and give ourselves the full depth we need. On these hinges are two adjustment points. One is to actually raise the pin to get it into its final location. Another is to give yourself lateral movement on the door to adjust your reveals. We're gonna drill holes in the side of the door to get access to those two pins. Obviously it's not screwed in right now, but when it's in its final place, you'll be able to extend this up into the housing on the top. So as you can see, these doors are 12.5 foot tall, being that I'm 6'5". So our finished heights here end up being 96 3/4 with the edge banding added, but we centered the hinges on this door, even though the finished door was going to be 2.5 inches. It was all planned for that way, so that way our reveals are all 1/2 inch and nothing binds or touches anything when the doors open and close.
At the end of the day, we could have definitely worked with another manufacturer to build these doors, but that's not the culture and that's not our mindset here. Our mindset is that we are craftsmen. It's the ability to constantly innovate and push these guys as individuals, as teams, as a company, to really strive for the very best that we can produce at.
From here, we'll wrap up our doors, bring them on site where they'll be finished and templated for mirrors. We're going to experiment with bringing our vacuum bag on site and trying to apply the mirrors to the doors in a vacuum bag under low pressure. So we'll follow this up in our installation episode.
I'd be interested to see how much weight you would have to put in the middle of this to get it to bend like 1/4 inch. Probably like 1,000 pounds.
I would build every door like this. Like even holding like this, there's no deflection in it.
This door right here weighs so much that only the strongest woodworkers can pick it up. That guy, Zach, that was in here earlier, can't even lift one of these things.